We've got 3 limits involving polynomials on the board. I'm going to ask you to pause the video and work these out, and then tune back in and we'll go through them together. I've got the answers up here so that if you felt confident with these and just wanted to check your answer, you can do that. I'm going to erase the answers and then work through these together. All right, so here, this is a polynomial, and we're going off to negative infinity. So I'm going to look for the lead term. It happens to be the one that's written first. This polynomial was written in descending order. So I'll say this is the limit as x goes to negative infinity of negative 2x cubed. Okay? And that's because if we're going to infinity or negative infinity, polynomials are dominated by their lead terms. Okay. So I would then say x cubed, since we're going to negative infinity and that's an odd power, that would be going down. So that's going to negative infinity. Multiplying by a negative number would reverse that, and so this limit is infinity. Now, I fully believe that you could do all of that work in your head. You could just say that's the lead term, that's going to infinity, and you could just write infinity. And if you did, that would be full credit. Okay. You really don't need to show any work in evaluating end behavior of a polynomial. However, I also believe that it's easy to make a careless mistake and put a negative sign there and say negative infinity. Because, I don't know, you see some negative signs, so you're thinking negative. If you do that and that's all you write, that's no partial credit because all you've given me is a wrong answer. So I would strongly encourage that you show somehow that you are just looking at the limit of the lead term. So writing this tells me you understand the process, even if you make a careless mistake in evaluating that. All right, next one. We're taking the limit as x goes to infinity of this polynomial. So I'm going to look at the lead term. Do be careful, that negative sign is part of that term. So this becomes the limit as x goes to infinity of negative 8 x to the 5th. Now any power, even or odd, goes off to infinity as x goes to positive infinity. Multiplying it by a negative will reverse that and will give us negative infinity. Okay. What you need to be careful of here is that you don't treat 3x as the lead term just because it was written first. Okay, this last one is not the limit as x goes to 2 of 4x squared. Here I cannot look at the lead term because that's not plus or minus infinity. So when we learn something new, it's important that we don't throw everything that we knew beforehand out the window. I know how to evaluate polynomials at finite numbers. They're continuous. I plug in. This is going to be 4 times 2 squared plus 5 times 2 minus 1. That's 4 times 4 is 16 plus 10 minus 1. That's going to be 25. So do be very careful. The rule that you can look just at the lead term only applies if that lead term is so much bigger than everything else that everything else becomes negligible. And that's only true if we're going off to infinity or negative infinity. All right. Now, this is how I would work through these. I would just say I'm going to look at the lead term. Let's just do this second one by doing the factoring in case some of you prefer to work through things that way. So here, I could say that this is the same as the limit as x goes to infinity. And what I want to do is factor out the biggest power. Okay. So I would factor out an x to the 5th, and so then that would be times 3 over x to the 4th minus 8. This piece would go to 0 because I've got 3 divided by something that's getting super, super big. So that means the entire quantity in the parentheses is going to negative 8. So x to the 5th, it's odd, but we're going off to positive infinity. So it's going off to infinity, multiplying, oh, I'm sorry, I said this thing was going to negative 8, and then I made my 8 take a nap, and it looked like negative infinity. This piece is going to negative 8. Multiplying something that's going to infinity by something that's negative is going to reverse that and give me a negative infinity. Okay. So, showing this work is optional. Even showing this work is optional, but I strongly recommend that you show some work, whichever helps you think through the process most effectively to justify your answer. That way, if you do make a careless mistake, you still have the opportunity for some partial credit.